My name is Steve Newton. My background is simple. I've spent nearly 14 years in Navy nuclear submarines out of high school. I came out of that and went into the electrical power business with construction company first, testing company, service companies. I worked all over the world on electrical systems. So what I want to talk to you a little bit about today was maintenance. Can anybody tell me why we do maintenance? What's the reason? Why do we do maintenance? Why do it? Why spend the money to do maintenance? Anybody? Go ahead. Prevent problems. Exactly. Anybody else? High cost of replacement. Go ahead. Business continuity. I'm sorry, ma'am. Say again. End of life of assets. Is that what you said? So the goal of maintenance is to eliminate accidents, unplanned shutdowns, and extend the life of the equipment. Up until about 2018, actually about 2016, maintenance was done at all different levels in all different industries. If you had a refinery down on the Houston Ship Channel, they did maintenance at that refinery. If you owned a putt-putt golf course, you did maintenance. You think guys that own a putt-putt golf course does maintenance? What kind of maintenance do they typically do, you think? AstroTurf repair? Yeah. We're going to talk a little bit about maintenance philosophies when I get into it. Now, the reason I said up until about 2016, different organizations from the putt-putt golf course to the, and I'm just using that as an example, to the refineries on the ship channel and the chemical plants had some type of maintenance they were involved with. They did maintenance in some way, shape, or another. Does anybody have any clue as to what happened in 2018 that changed the face of maintenance somewhat? Anybody? Well, good. I'm going to pass something on to you you don't know. In 2018, the new NFPA 70E on the managing electrical hazards came out, and it had been fully adopted by OSHA. Over the past, every 3 years, they updated that document, and each 3 years, it became progressively more strict in trying to get to an end goal that the National Fire Protection Association had in conjunction and at the request of OSHA. In 2018, they added an element to electrical safety that affected the electrical industry across the board, but is just now beginning to become aware of the electrical industry. Now, I'm going to talk to you about two things today, basically. I'm going to talk to you about maintenance as it applies to compliance with regulations, standards, and practices, and I'm going to talk to you about maintenance in the sense of economics. If maintenance isn't economical for our businesses and our companies, will we stay in business? No. Maintenance has got to be economical. And for years, it's been all or nothing with most entities when it comes to maintenance. Now, I'm going to tell you ahead of time, I'm going to be coming off of a paper that I wrote, is what I'm going to be working off of. That paper is available just on the other side of the fence over here on our booth at National Field Services booth. That paper is available. If you want it, you're welcome to it. I should have plenty of copies there. If for some reason that's gone and there's not enough copies, make sure you give them their business card and tell them you want a copy of it, and I'll email you a copy of it. The reason why you may want a hard copy is I'm going to talk about a flow chart that I'm going to put in there to help you make some decisions on how you do maintenance. So let's get started. Like I said, NFPA 7018 in 2018 has a definition in it that'll be interesting to you, I think. There's actually two things. It says the state of electrical equipment considering the manufacturer's instructions, manufacturer's recommendations, and applicable industry code standards and recommended practices, establishes the condition of maintenance for electrical equipment. Now, what do we care about the condition of maintenance? In Article 110.1 of the same 70E document, it states that the electrical safety program shall include elements that consider the condition of maintenance of electrical equipment and systems. What's that saying is, if you don't maintain your equipment properly in accordance with acceptable industry practices and standards, then your equipment may not be safe. And if someone gets hurt, OSHA can use this, the fact that this is in here. So I just want you to keep that in the back of your mind for a minute. I'm going to help you with this so this doesn't become a problem necessarily for us. Almost all work around electrical equipment is only permitted with the new changes if it's in what's called a normal condition. And we're going to go into a normal condition later in this discussion. But I want to briefly hit the 6 points that are required for it to be a normal condition. 70E Article 130.5 defines equipment condition is considered to be normal only if all of these 6 things are true. 1, the equipment is properly installed in accordance with manufacturer's recommendations and applicable industry codes and standards. 2, the equipment is properly maintained in accordance with the manufacturer's recommendations and applicable industry codes and standards. 3, the equipment is used in accordance with instructions included in the listing and labeling and in accordance with manufacturer's instructions. 4, equipment doors are closed and secured. 5, equipment covers are in place and secured. And finally, there is no evidence of impending failure such as arcing, overheating, loose or bound equipment parts, visible damage or deterioration. Now, like I said, I'm going to touch on these a little more in depth later on. What I want to get to is what we came here for, and that's to talk about maintenance. So, what is it in the electrical industry that causes failures? What causes failures in our equipment? Electrical equipment is only susceptible to a handful of things. They're moisture, contamination, and heat. Those are the 3 primary things that cause us problems with electrical equipment: moisture, contamination, and heat. The goal of our maintenance should be to prevent them, retard them, or mitigate their effects. The purpose of our maintenance program should be to prevent them, retard them, or mitigate their effect. So, which maintenance strategy is the best strategy? Is anybody here familiar with the 4 basic maintenance strategies or have some concept of what they are? Anybody? Go ahead, sir. Predictive, preventative, yes. How about run to failure? Run to failure, guys, is a valid maintenance process. Run to failure is, when I say it's valid, it's not maintenance per se. It's sort of more of a no strategy approach. If you apply run to failure across the board, and I'm going to touch on this with your automobile here in a minute, but what would happen if we decided to go run to failure on our cars? Across the board on every aspect. I'm not going to change the oil no more. I'm not going to check the air in the tires. And I have one of these cars that don't have the fancy thing that tells you you have no air in your tires. I'm not going to do any of that. I'm just going to drive my car till it fails. Is there anybody here that wants to operate their vehicle that way? No. However, guess what? That's the way I'm going to do maintenance on my lights on my vehicle. I'm not going to sit there and worry about the bulb in my tail light. When it burns out, I'll replace it. Run to failure. So we're going to get into that in more depth in just a minute. I want us to talk a little more about this whole concept of run to failure. Degraded equipment is only repaired or replaced when the effect of degradation on the process output becomes unacceptable. That is usually manifested in catastrophic failure. No explicit attempt is made to monitor performance or avert failure, and the risk associated with ultimate failures are acceptable. Because of the generally high reliability of electrical power equipment installed in benign environments, the run-to-failure approach often provides satisfactory power reliability and availability in a non-critical application. This is also referred to as reactive maintenance. The next level up from that is what we call inspect and service as needed. Inspect and service as needed is a strategy one step from run to failure. Operating our maintenance personnel inspect electrical equipment on a regular schedule. Under this approach, incipient failures are usually corrected before they become catastrophic, especially if the impact of failure is considered unacceptable, and there is often some informal monitoring of performance to predict future failures. Now, before I cover the next two levels, I want to inject something here. Run to failure and inspect as needed have their place in our industry. The next two things I'm going to cover will get a little bit more in depth. However, what I want you to understand is what we're really here to talk about is going to be what I call reliability-centered maintenance. In other words, there is no silver bullet. There's not one maintenance concept that we should really apply to our systems. The next level up is one called preventative maintenance. That was mentioned. Preventative maintenance strategy establishes maintenance activities are performed on fixed intervals, calendar times, operating hours, or operating cycles. Both procedures and schedules are usually based on manufacturers' recommendations or industry standards. Preventative maintenance is the primary method that we used on our nuclear submarines. We did maintenance, the same maintenance on a regular interval. We did it the same time of the month. Anybody here anybody here in the Navy? Raise your hand if you were in the Navy. Okay, did y'all do preventative maintenance? Yeah. PM was what we called it, and we did it all the time. This was what we followed. Both procedures and schedules are usually based on manufacturers' recommendations or industry standards. Now, I have mentioned this concept of industry standards at least half a dozen times just in this brief amount of this conversation we've had. So let me help you a little with industry standards. What happens is we will take a simple low voltage power circuit breaker. If you look at a low voltage power circuit breaker, there are standards like IEEE C3720.1, IEEE C3720.13, ANSI NEMA C37.50, and a few others tossed in there. Now, IEEE is one organization. ANSI is the American National Standards Institute, another organization. NEMA is a manufacturers-related organization. If you want to know about electrical power circuit breakers, their standards, these standards cover those and are accepted industry consensus standards. And they cover low voltage circuit breakers. There's no conflict between them. There's no ambiguity. They fit with each other. They each have different aspects they look at, but they all are in lockstep saying the same things that have to be done. We also have maintenance standards. The ANSI NEDA maintenance standards. We have NFPA 70B maintenance standards. So there are maintenance-related standards that are accepted industry consensus standards as well. So whenever I'm talking about industry standards, this is what I'm talking about. While a preventative maintenance approach ensures that equipment gets periodic attention, it does not necessarily prioritize maintenance according to safety or productivity significance, nor does it optimize the application of limited maintenance resources to take advantage of lessons learned. What that's basically saying is it doesn't really say this here historically needs maintenance on a regular basis. This doesn't, so I'm going to focus my time and energy on this one that does. However, we have our next and final level I'm going to talk about, which is condition-based maintenance. Now, condition-based maintenance is somewhat of a newer concept. Have anybody here that mentioned they knew something about maintenance and gave me some feedback, had any of you in this room ever heard of the term condition-based maintenance? You have? Okay. Anybody else? A couple people have heard, most have not. Condition-based maintenance is the thing that requires a little bit higher technical skill sets to deal with because it requires more subjectivity interpretation of data, but it is becoming a wonderful thing for industry because it saves us lots of money. It allows us to focus on things that need focusing on. I call it, don't fix it if it's not broke. That's sort of what condition-based maintenance is. This strategy is also called predictive maintenance. It's an extension of preventative maintenance strategy and uses non-intrusive monitoring and testing techniques to assess equipment condition. It uses planned maintenance tasks that are based on equipment's previous operating history and trending of the maintenance data. It is more effective when combined with preventative maintenance programs because it prioritizes maintenance based on criticality of equipment, productivity, resources, or lessons learned. What we are doing with condition-based maintenance today in the electrical industry is our goal is one step beyond this. Our goal is to not have to turn the equipment off unless we need to. But it's not because we're ignoring the state of the equipment, it's because we are finding passive ways, non-intrusive ways, to analyze the condition of the equipment and then make our decisions based on that. So this is where we're moving to in the electrical industry. There's several tests that I won't bore you with and things that we do now that we can do passively. Probably the most commonly known passive condition-based maintenance we do is infrared surveys. Most everybody does IR surveys. And if they're done properly, they're non-intrusive. Now, the problem we have with IR surveys when we first started doing them was they were dangerous. They injected some risk to the people involved in pulling panels and doing things like that. So we've come up with some engineering technology, some engineering mitigation in order to help make it safer where there's less risk involved. And I'm going to talk about that in a minute. So I mentioned the 4 basic maintenance philosophies, but what I haven't mentioned is what you came here for, which is what we call reliability-centered maintenance. Reliability-centered maintenance takes all of these maintenance philosophies into account, looks at our system, and figures out how to apply them. Like I said, there's no such thing as a silver bullet. If you want to go to the highest level of predictive maintenance and condition-based maintenance, and that's what you want to do, you will spend a fortune doing that if you do it on everything you have in your system. If I do it on every outlet in my facility, if I do it on every lighting panel in my facility, then I'm going to be spending a whole lot of money that I may not necessarily need to spend. So what we're looking at doing with reliability-centered maintenance is approach this from a little different angle. Its original concept involved heavy reliance on detailed failure modes and effective analysis, math-calculated probabilities of failure, and model development and accumulation of historical data. It was very involved in its original concept. Because of the detail involved, it was highly labor-intensive, time-consuming, and comparatively expensive. The most appropriate applications of reliability-centered maintenance are when the consequences of failure would result in catastrophic risk to personal safety and health, to the environment, or could result in complete economic failure of organizations. Now, I told you at the very beginning my background. Where do you think we first started using reliability-centered maintenance? Anybody? Do what, ma'am? Nuclear reactors and nuclear weapons. In our nuclear program, we started using, along with paying attention to human behavior and human performance issues, we also use what basically will become reliability-centered maintenance. And because it was the Navy, that means it was the federal government, which means we didn't care how much money we spent. But we in private industry care how much money we spend. The most appropriate application, like I said, is when the consequences of failure are catastrophic, which they would be in a nuclear facility. It is more realistic and cost-effective if we adopt a streamlined version of reliability-centered maintenance approach and recognize the benefits while realizing few building mechanical and electrical systems carry the catastrophic risk addressed in the rigorous RCM process. If I have a gas leak in my house, that's pretty serious, right? The results could be catastrophic, yes? If my air conditioner goes out in the summer up here, that's not catastrophic. I'm sure some of you would argue with me about that, but it's really not catastrophic. So the first thing you have to do when you're dealing with reliability-centered maintenance is you have to consider the fact that you want to be able to get all the benefits from it, but streamline the cost of it. So lower intensity, more in line with the scale of the facility's infrastructure, also means lower cost. So what we look at is we have to analyze our system. We have to look at the system, and it starts with the very beginning when we design the system. When we go to, and I realize most of you probably already have systems that are in service, but I want you to think about this as you move forward for those of you who are involved in construction, when you're moving forward and you're having new facilities built. The place that maintenance needs to start is when you design the system. And what I mean by that is you put things in place that will help facilitate a less expensive and impactful maintenance cycle. Let me give you a few examples, and these need to be written into your specifications. And specifications are everything, folks. You want to write detailed specifications that are clear and unambiguous, but will take care of addressing what you want to have in the future to minimize the cost of your maintenance. Things like all electrical panels shall have infrared windows installed as to allow for online evaluation of connections. Now, I think it's pretty much a no-brainer that if I'm building a new facility and putting some switchgear in this facility, that when it's new, it's going to be less expensive for me to put the windows on it than to have to interrupt the processes later to put the windows on it. So we look at this from a standpoint of trying to save cost on down the road. Where infrared windows are not practical, hinges or handles must be provided to facilitate safer access of the panels. It is safer to pull a panel off that has a hinge on it than it is one without no handles or hinges. Now, if you don't have hinges, the next best thing is to have handles on it. That's safer than pulling one off that don't have handles. Another spec would be ensure that any component can be isolated and replaced or worked on without impacting the system. No daisy chains. I cannot tell you how many systems we see installed where they daisy chain the primary of one transformer to the other, to the other, to the other, to the other, and there's no way to take one of them out of service without affecting the daisy chain of all of them. Now, we've come up with some engineering fixes on some transformers to make that a little easier, but still a problem in a lot of installations. Specify the environmental conditions that must be maintained for the equipment. When you design your electrical room, don't ignore the HVAC system. Don't ignore keeping the equipment cool and dry. Sizing equipment to minimize overheating. When you size a piece of electrical equipment right where you need it to be, you just set yourself up for a headache from there on out. Size it over the size it needs to be a little bit, and that allows it to stay cooler as it runs at load. Specify maximum harmonic distortion. Now, harmonics is something I'm not going to get into a lot of depth about, but it's something you have to pay attention to when you're talking to the engineering firm that's doing the design and you're designing how you're going to run the systems. Okay? So, those are just a few examples. There's a lot more. What I want to cover with you now is the fact that we have to make these decisions. So I have my system. Somebody give me an example. Does anybody here own a system that they're having to do maintenance on? Any of you owners? Any of you coordinate the maintenance on a system? You're an owner? What do you own, sir? What's your building? Travis County? So you take care of the county's equipment, right? okay? So what we would do is you take a look at all of Travis County's switchgear and equipment, and you go through a flow chart, which is in this paper I've got. There's a flow, I'm gonna sort of walk you through it, but if you want the flow chart, just get with me. I'll give you a copy or I'll email you a copy. You go through this flow chart on this decision making, and the purpose of the flow chart is to decide what needs this kind of maintenance versus what needs this kind of maintenance versus what needs this kind of maintenance. We do the maintenance necessary to achieve our goals, but we don't overkill on the maintenance and we don't cut it short. So the way this will work is you ask the first question. Will failure have a direct or adverse impact on environment, health, security, and or safety? That's the question we ask. If the answer to that question is no, then we have to ask another question. Will failure have a direct and adverse impact on my mission or my production? If the answer to that question is no, then we say, will failure result in high economic loss? If the answer is no, then that piece of equipment or that part of the component can be used run to failure processing. In our car, we would go through here and say, yes, okay, my tail lights, my lamps and my tail lights fit the criteria for run to failure. I answer all these questions about my tail lights and it's no, 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 no. So I'll run those to failure. I don't think I can answer that about my brakes that way, but I can about my tail lights. So then let's go back and let's ask this question again. Will failure have a direct and adverse impact on environment, health, security, and or safety? That's the question we always have to ask. If the answer is yes, it will, then we go to the next decision. Is there an effective condition-based maintenance approach? If the answer is no, we say, is there an effective interval-based task? If the answer is no, then we redesign this system, accept the failure and risk, or install redundancy. So we have to do something. However, if when we ask, is there an effective interval-based task, the answer is yes, then we develop and perform interval-based maintenance. When we go back and we ask, is there effective condition-based maintenance, and the answer is yes, then we use condition-based maintenance where this is. It all keys off of, can I afford to let this piece of equipment fail and then replace it? That's where it starts at. And when we talk about our automobile or our car, you look at wipers, lamps, things like that. Some people will change their wipers out, but if you're like me, you just run the wipers till they fail and then you go get new wipers. Not everybody does that. Inspect and service, our fluids, we check our oil, we check our fluids. Belts, we do an inspection on our belts. That's inspect and service. Preventative maintenance. We do our oil filter every 30,000 miles or 5,000 miles. Preventative maintenance. We check our exhaust system. Preventative maintenance. Condition-based maintenance. My tire tread. I measure my tire tread. Is my tire tread low? Another condition-based maintenance is the new things we have on the new cars that tell us our pressure is low in the tires. It's condition-based maintenance. Brake wear can be under condition-based maintenance. In industry, what we're doing today in the electrical industry, when it comes to condition-based maintenance, is we're doing things like what's called partial discharge testing. We can evaluate electrical equipment, certain types of electrical equipment, by evaluating partial discharges. Now, I don't have nearly enough time to explain that, but know this. We can do it while your equipment is running and doing its normal job it's supposed to do every day on most equipment. We don't have to shut it off to do it. The other thing we're doing is we're doing stuff, especially with motors. Some motors are critical and some are not. Just depends on the motor. You take, for instance, the lube oil motor on a generator is a critical component, even though it's a little bitty motor. It's not about how big, it's about what it does and what would happen if it failed. In about 10, 12 years ago, I worked with a company that was developing a condition-based spectrum analyzer, which is part of what I did in the Navy. I worked with spectrum analysis, which is nothing more than looking at broad frequency ranges in evaluating what's happening at all these frequencies. So I worked with a company, and we did about 1,500 motors, tested about 1,500 motors in Northern California at a refinery. We spent several years going through doing passive spectrum analysis. The motors kept running, kept doing their job. We checked their current signatures and ran it through a spectrum analyzer, looked at the signature of what it looked like, and evaluated the motors. We learned how to tell if there was a problem with the rotor. We learned, even more importantly, how to tell if there were problems with the bearings before the vibration would manifest itself by looking at the electrical signature. We'd take those motors out, we'd take them to a motor shop, the motor shop would tear them down, we'd find out how close we were, how far we were, and what we learned over that couple of years with this particular type of condition-based maintenance is we could predict the failures very accurately of motors before they failed. Now, before we did this, we went through and did an analysis of what we call lost profit opportunities, or LPOs. In a refinery, what happens is if something goes down, it's lost profit. It's profit they're not going to get because the equipment is down. So we evaluated this, and most of their lost profit opportunities could be traced back to the failure of a motor. When it was all said and done, the cost of doing the condition-based maintenance was a fraction of the lost profit that we eliminated by doing it. And to this day, they still do it faithfully on a regular basis, as well as a lot of other big companies are doing it. That's another one we use. I've already mentioned infrared. So if you have an infrared window, or you go through infrared on your motor starters, and they're nice and cool, and they're clean and all of that, then all is well. You keep right on running. If you see a hot spot on one of them, you evaluate how hot that spot is, and you may need to schedule at a convenient time for you to shut it off and fix it. That's the whole thing, is it gives us the power to not be reactive and at the mercy of the equipment. It gives us the ability, by doing this, to deal with the equipment that's critical to what we do. And reliability-centered maintenance says this component can run to failure, this one here I need to do this with, this one I need to do this with, this we can keep running forever and we'll just do. In other words, you selectively set it up so that you are doing what you need to do when you need to do it. So we basically, and what we did in this motor thing, by the way, we went through and identified what we called critical motors, which motors were more critical and less critical than others. And some motors we left to run to failure. We didn't mess with doing it. We left them run to failure because they weren't going to hurt anybody. It wasn't going to hurt our production. It was going to be a little bit of a nuisance, like maybe the office would get a little warm because the air conditioner motor went out, or the capacitor went out on the air conditioner. So we went out, found it, fixed it, turned it back on, and all is well. And the air conditioner's in a safe place, nobody's around it, so if something happens to it, it happens to it. So there is a place for this, and what we're talking about doing reliability-centered maintenance is using the best maintenance technique on that piece of the system to get the job done, okay? I can't overemphasize, though, there's a couple things that are so simple, it eludes us sometimes. Keeping your electrical equipment in a cool, dry space is worth a tremendous amount of money, guys. Keeping your equipment, if your air conditioner goes down to your electrical space, that's no big deal. We'll get to it next month. What you're setting yourself up for is a whole lot of heartache and headache. Fix that air conditioner, because that simple thing of keeping it cool and dry is a tremendous benefit. Also, trust your senses. If you walk by a piece of equipment every day, and one day you walk by it and it's a little noisier than it was the day before, you have a problem. Your ears have just executed condition-based maintenance and told you had a problem. If you walk into a switch room and you smell ozone, you have a problem. Your nose has just told you, using condition-based maintenance, you have a problem. Teach your electricians, teach your maintenance people, teach them to trust what they hear, what they smell, and what they see as much as anything. And let me tell you something. The reason why this reliability-centered maintenance is so important is what we call infant mortality. Let me talk about that in just a minute. Let me back up for a second. So let's first talk about the concept of normal. Okay, I mentioned these 6 things that are required for equipment to be normal, and that's going to help us understand a little bit more about what we need to do. So the first one I gave you was the equipment is properly installed in accordance with manufacturer's recommendation and applicable industry standards. The first critical juncture for any electrical equipment is when we install it. When we install this equipment, we have to start it and turn it on at some point. That's what we call the infant mortality state of the electrical equipment. That's why at that point it has to be, the smallest, most basic installation needs to be checked against this, grounding in your system. You need to make sure that you have somebody that knows what they're looking for doing this. Get the engineering firm engaged that did the design, or get somebody involved with this that can help make sure that you get past that infant mortality stage and that the equipment, when it is installed, was installed correctly. 50% of all electrical failures are caused by one of 2 things: when they're installed in construction, or due to maintenance, when people maintain them. I was doing an evaluation for a company in one of the big high-rises in downtown Houston. It was the middle of the night. They had an electrical firm in there doing maintenance, the old standard maintenance. They shut the equipment off. They opened it all up. They went through and cleaned all the equipment with vacuum cleaners and wiped it down and checked the torque on all the bolted connections. And so I was evaluating this electrical contractor. So they went through and did a jam-up job. They did good. They cleaned it, looked great. Everything was fine. I'm standing at the vault door, and they had the vault in there. And the reason I'm at the vault door is because the contractor sent their electrician in there to close in the switch to energize everything by himself. And I wasn't comfortable with that. So I said, well, I'm going to stand here by the vault door just in case something happens and he needs help. And I'm standing there, and he closed that switch, and it was like a howitzer cannon went off, the explosion. Long story short, when we went back and checked to see what happened, they had some 480-volt bus, 3-phase bus like this, and they were torquing it, and it was stacked pieces of bus. And when they torqued it, this piece of the stack moved over when they torqued it and came in contact A phase to B phase. So when he closed it, we had a bolted A to B fault. That fault was caused by maintenance. We have the same problem when we do the construction. So it's very important in the infancy stages that we evaluate this equipment and make sure it truly is ready to turn on. Now, the reason I mentioned the infant mortality stage on new equipment is when you take the equipment down, you gut it, you gill it, you clean it, you wipe it, you torque it, you are now going through another infancy mortality stage on that equipment again. It's like starting all over again at brand new. So all the risk that existed in the beginning now exists at the end of your maintenance cycle. Some equipment you need to do that with, okay? Don't get me wrong, especially if you don't do what I told you to begin with and put it in a cool, dry place. Then you end up having to do that a lot more, and therefore you run your risk greater. See how important it is to make sure your equipment's cool, dry, and in a good, clean place? So you got to make sure, number 2 was that the equipment is properly maintained in accordance with manufacturer's recommendations and applicable industry codes and standards. Establish a maintenance program. Stick with the maintenance program and document all aspects of the maintenance program. Somebody in management decides they need to do a maintenance program, just like my wife decides that she wants to join a gym. So in January 1st, she joins the gym. You want to know how often she's going to the gym by March 1st? 0. That's how gyms make money, by the way. But anyway, the same thing happens in maintenance programs. Somebody in management says, we got to have a maintenance program. So they write a maintenance program, throw it together, put it together. We execute it a few times, and then it gets thrown off in the wayside. One other thing I want to tell you about new installations, and I mentioned it in my paper, is that make sure when you do a new installation, you capture every bit of the manufacturer's books, seal them away like they are gold in a vault, and keep track of them, because they are essential to you throughout the future of that equipment and the entire life of that equipment. Do the same thing with your electrical drawings. I cannot tell you how many facilities I walk into, they can't find their drawings. They have no books on their equipment. And guess what? They have no idea what's in those books. Establish a maintenance program, stick with the program, document all aspects of the maintenance program. Make sure you get it set up with somebody that knows how to set up a maintenance program. I don't figure out how to make my grass green. I hire a company to come help me keep my grass green, you know. Some people can research it themselves and figure it out, but make sure everybody who's doing it knows what they're doing. At a minimum, make sure you re-inspect and test the equipment prior to the warranty running out. Number 3, the equipment's used in accordance with instructions, including listing and labeling. Maintain a document library, as I said, with all the manufacturer's instructions. Make sure people working on your equipment have access to these documents and know what's in them. Finally, keep the equipment doors closed and secured, covers in place. We mentioned that. Now, I want to talk about the 6th thing, which is evidence of impending failure. As I said, teach your people to trust their senses. What they hear, what they see, what they smell. Impending failure doesn't mean, well, I think this might be dangerous. Or you have, I've taught a class of electricians one time that were going to be racking equipment in house. Oh, man, I'm not going to touch that. Well, there are some things we do that are dangerous. There are some things we do that are more dangerous, and some things we do that are less dangerous. Make sure that the people working on your equipment are doing it, have access to these documents so they can be qualified to work on them, okay? Impending failure is not because I'm afraid of it. It's because there's something really going on with it, okay? Trust your senses. So there's a couple things I want to conclude with before I open this up for any questions. For any maintenance program to be both effective and economical, and guys, we want both. Guess what? If I provide you with maintenance services and I charge you so much money that it puts you out of business, is that smart on my part? No, that's a dumb thing to do. The smart thing is for me to provide you with what you need, only what you need, at the most reasonable cost I possibly can. That way you stay in business and you and me are working together for the next 20 years. You're happy and successful and I'm happy and successful. That's what we really want. That's not like the roofing companies that come around after, and I'm not dissing roofing companies, guys. It's just the ones that come around after the hailstorms from someplace we don't know where. They're not even here in Dallas and you never see or hear from them again. Not the same thing. So, for it to be effective and economical, it should be customized for the specific application, not one size fits all. Look at your application, evaluate your criticality of all your different components in your system, and decide what maintenance needs to be done. That is reliability-centered maintenance. This requires a reliability-centered program and is initially a front-end investment in money and time to ensure the maximum reliability. You have to invest in the beginning to set up the maintenance program. It requires a little more work to set it up to where you're evaluating everything you had. The first thing we did at this refinery in Northern California was went through and evaluated over 3,000 motors and settled on about 1,500 of them that were critical, that needed to be addressed with a complete system maintenance program. Didn't do it on all of them. You don't do it on your car. You don't do it on your home. So why would you do it on your business? You know, look at what you need. So at this point, I'd like to open it up because I really like being able to answer questions. And I would encourage you, if you got something on your mind, hit me up about it, ask me. I may or may not know the answer, but I'll tell you the best of my ability, folks. Anybody? Yes, sir. Go ahead.
Total rookie, and so I'll say that first. And I'm a principal at a school, right? So I help maintain kids, not electrical systems. So in a school setting, most critical. You talked about what's most critical. Any just like real quick. Here's a quick list of the most critical functions that you see in a school.
You start at the high side and work your way down. So the most critical thing you're going to have is going to be your main incoming distribution system that's feeding all of your panels. Because if you lose it, you lose everything in your facility. And in fact, now that you mentioned the school, I had to actually sit in as a witness on a lawsuit between a manufacturer and a school district over the fact that the school district had their main breaker feeding their school had tripped. The person that, the facilities person that worked there went and closed the breaker and it tripped again. He went and closed the breaker and it tripped again. Third time, he went and closed the breaker and it tripped again, except this time it blew up and started a fire at school. So I ended up going to do the inspection after it happened and looking at the situation. And so, long story short, I ended up in court because the school district sued the manufacturer because the breaker was defective and failed and caused a fire. In the manual that I just told you to hang on to and make sure all your electrical people know how to read, it states very clearly in a big old huge box, if you have a protection trip on this circuit breaker, do not re-energize this breaker until you have ascertained the cause of the trip. Now, I was there to testify for the school district. They decided they didn't want me to, and then I got subpoenaed by the manufacturer. So that's the way it sort of ended up going on that one. So to answer your question is that your main incoming system is your most critical thing because it affects everything you have. The next thing you got to look at, what things are around your kids? What do your kids go by all the time? What are they passing by? I would assume that you have GFCIs in your bathroom, right? Those are pretty critical that those are checked. That's a critical thing. What thing are your children exposed to? What electrical systems are they close to that could impact them? Follow me? So that's sort of the biggest thing with schools or small commercial entities like that is their main incoming system needs to have a really rigorous maintenance program on them. Anybody else? You're kidding me. Nobody's got any questions at all. Well, see, can I tell you another story maybe? Maybe not. You have a contractor.
So that's kind of what I'm asking. Like, who would I be looking for as far as is like any electrical contractor, somebody who can come out and do help us develop a maintenance schedule on that?
Yeah, electrical maintenance contractor can help you out. I would suggest I wouldn't say the word any electrical contractor, but I would screen my electrical contractors and get you a good electrical contractor, but there's a whole lot of them, good electrical contractors in Dallas-Fort Worth that you can deal with. Which, by the way, we're not an electrical contractor like that. We typically don't do all that kind of stuff, but we work with a lot of commercial systems, and we do have an engineering arm, and we help with some of that, but you can get electrical contractors. All you need is a good electrical contractor to help you. Your school district should have one already assigned to you.
It's like I said, it's an independent school.
Oh, it's a private school. Okay, I got you. Yeah, make sure you have a good electrical contractor. Any good electrical contractors in here? They tell me I can't do that, but guess what? It's at the point now I'm at the end of this, I can do whatever I want. Anyway, the worst thing they'd do to me is not ask me back. So, yes, ma'am. Mm-hmm. Usually a UPS on your electrical panel? No, not usually. Depends on your systems. About the biggest place we see UPS systems, the biggest place where you'll see UPS systems in service today is in data centers. See them in data centers. We do deal with lots of UPS systems in data centers. No, it's not a UPS system. Now, it may have what's called an ATS or an automatic transfer switch. You'll see a lot of those in high rises. You see a lot of those in hospitals. So they may have automatic transfer switches. Do you have an emergency generator in your facility? You may or may not have a transfer switch. It depends on how many services you have. Normally, if you've got 2 utility services coming in or you got redundancy in the system, you will have transfer switches. And those transfer switches are critical. There's an entire document, NFPA 99, that covers, for instance, hospitals and medical facilities. There's all kinds of rules we have with medical facilities we have to follow. Lots. Anybody else? Go ahead, sir. Was it the joke that made you decide to start talking? Okay, just wanted to see if that's what I needed to do in the future.
So, I mean, do you, in your evaluation process, you refer to a loss of profit opportunity? Do you specifically use that in evaluating as a tailoring a specific game?
Not in all applications we could, though. It could be used, depends on what you're doing. If it's a large enough production facility and you make your money off of production, then absolutely you want to do that. If you are making widgets at your plant, okay, and you are selling every widget going out the door every day, and you have a shutdown, that's a lost profit opportunity. So you got to see what it is you're doing in order to figure that out, whether or not that's the best way to evaluate. But I'm going to tell you what, if you have a production facility like that, and you want to sell management on it and get management on your side with doing maintenance, that's the way to do it, is to evaluate your lost profit opportunity and show them in dollars and cents. Because what I've talked to you about, there's regulatory reasons you do maintenance now. 70 and OSHA have made it a regulatory issue to do some type of maintenance. There are safety issues also on top of that. There's the well-being of your people, because you care about the people working in your facility. You don't want them to get hurt. There is financial reasons to do maintenance. There's a lot of reasons to do maintenance. The key is doing smart maintenance. And so, yeah, to answer your question, LPOs may be one thing you want to do. It may be one way to sell it to your accountants. Anything else? Well, folks, I've appreciated y'all's attention, and I tell you what, it's very humbling for me to be able to talk to you about, because I'm just like you guys. I've been doing this for a long time, but I'm going to tell you something. There is more about electricity, even though I've worked with it my whole life, electricity and electronics and computers. There is more about this industry that I don't know than I ever will know. It's that big of an industry, and it requires a whole lot of people working together to keep our wheels turning in this country and to keep the electricity moving and keep our businesses going. It's not any single guy that's going to do that for you. It's a concerted team effort to do it. And it humbles me greatly that I get to talk to you guys, because I sit out there like y'all sometimes, and your time is valuable. My time is valuable, and the fact you're willing to take 45 minutes out of your day to sit and listen to me ramble is very humbling for me. So I appreciate it very much.